Hello everyone, welcome to our series of DepthInsight teaching videos. This video will introduce how to build a velocity model by well data and velocity spectrum data together. The main steps of workflow are listed below. Import velocity spectrum data. Build interval velocity model. Build average velocity model. And time depth conversion. Then let's start the software and do them. Open the software and select the modeling on the main interface. Open an established structural model. The domain type of this model is time. And set the seismic datum to 600 according to the actual situation. Create a horizontal horizon and set the Z value as 0 as a seismic datum. And then regenerate the horizon surfaces. And regenerate the zones. After that, switch to velocity modeling module. New an interval velocity model. We can rename the model. And select the horizons we want. Set the sigma parameters. In general, we set the information of work hours according to the seismic survey. If we don't know the information, we could mark reference model survey. The next step is import velocity spectrum. Mark maps. And set the stratigraphic sedimentary pattern from proportional, follow top, and follow base. Here, I rather choose them, just for showing the functions. Here is a things to note. Remember to mark text conversion and set the velocity spectrum date format and find the file. Click OK. The software will extract velocity values of each horizon automatically. Then set the colors according to the velocity values. The next step is edit interval velocity value of each horizon. Click one horizon and select Edit Waypoints to open a histogram. We can set a constant value or a linear equation as a velocity value. We can also set the top limit and lower limit value according to the histogram. Click Filter and Apply to change the value. After that, we can also click Smoothing to smooth the values. In this way, we can edit other horizons' interval velocity values. The next step is set the parameters. Select the setting. There are three models of gradient: variable gradient, constant gradient, and none. Here, I select variable gradient for each horizon. And mark smoothing to set smooth coefficient of each horizon. After that, click OK. And the next step is generate interval velocity model. It will take a few minutes. After generating interval velocity model, we can create many sections to check it. Before creating sections, we should make sure horizontal step and vertical step on section are consistent with the segue parameters information. Set the colors on sections according to it. Here are three type sections of inline section, cross-line section, and general section. Here, I select general section to check the velocity model. Projection the view window and create a general section. And click Calculate. We can create many sections to check the values. If there is no problem on sections, we can continue to the next step. The next step is export interval velocity segue volume. Select Export. Select the unit. Mark Check Data. And choose a piece and name it. After that, click OK. The software will output the sequence volume automatically. It will take a few minutes. The next step is load well interval velocity. Switch to well management and load the well velocity data. Before loading, please make sure the TD well data has been imported into data management. And make sure the well and model have a same domain tab. Then, set the database information to contact the well management to the database. Select the project. And select the time domain. After that, we can load the well path. Load well types. And last, load well velocity. Check the value region on Properties pane and set colors according to the value region. Switch to velocity module and do the next step. The next step is correct interval velocity sequence volume by well. Select the velocity volume file, export it before, and rename it. Click Save. And the software will correct the volume automatically. It will take a few minutes. After finish, we can create sections to check the volume. Select Extract. The result is velocity volume after checking on the section. The next step is create a new average velocity model. And export average velocity sequence volume. Select Export. Choose the source of interval velocity. Select the velocity unit. And select the path and name it. After that, click Export. The software will export the average velocity volume automatically. It will take a few minutes. After finish, we can also check the average velocity volume by sections. Before checking, we should make sure horizontal step and vertical step on sections are consistent with the sequence parameters information. And set the colors on sections to make it same to the well colors. There are also many kinds of sections. Here I select a general section to check the average velocity model. Projection the view window and create a general section. Click Extract. We can see the value on the section. We can also create many other sections to check the model. If there is no problem on sections, we can continue to the next step. We can correct the value by well. Click Correct by well. The software will correct the average velocity volume automatically. After finish, we should extract again. Then the value after checking will be shown on section. The next step is time depth conversion. choose TD conversion. First, select the source of average velocity. There are two ways to convert the model. One is date-time depth conversion only. The other is model and date-time depth conversion together. Here, I select the second one. And select a save path. Click Export. The software will create a model in depth domain automatically. As we can see, the horizon surface is in line with the well tops. The above is the main workflow of velocity modeling by well and velocity spectrum together. Thank you for watching, and here is our contact information. If you have any questions, please contact us. Thank you.